Today's lesson, 4-6, matrices for reflection. So you can see the goals that we have today. Lots of reflection work, being able to deal with matrices and vice versa, and taking the figures and being able to reflect them accurately. So moving forward, let's start with our 2 points that represent our identity matrix, which were the points 1, 0 in blue and the point 0, 1 in red. Okay, if we were to take those 2 points and reflect them, because they are just any generic points really, they happen to be our identity matrix. So let's write that up here before we start. Our identity matrix are the points 1, 0, 0, negative 1. Remember, reading these 2 points going down. All right, so let's take the point 1, 0, and let's reflect it over the x-axis. So right now, most of you know this is the x-axis. So if you take this blue point and reflect it, which we know means fold over, think of it as a line of reflection, on that point, where would it be? Most people would say, and our new little symbol for this is reflection over the x, that point, 1, 0, would reflect upon itself, so it would stay 1, 0. Now, take the red point. So when when we reflect it, it stays right where it's at. Okay? Now let's take the red one and reflect it over the line y equals x. Most of you would say that that point reflected over that line goes to this position. And that is the point 0, negative 1. So if we write our new matrix, we have the point 1, 0, which is where our line is at, be staying right where it's at, 1, 0. We have the point 0, negative 1, which is, I even wrote that wrong, 0, 1, which turns into 0, negative 1. All right, so this would be our new, what we call 2 by 2 that represents reflection over the x-axis. All right, let's clear, and let's now reflect over our line that represents the y-axis. And again, place our 2 points. So 1, 0 is our first point, and 0, 1 is our second point. So again, doing them in that order, because the identity matrix is 0, 1, 1, 0. We will now take those points. So take the point, oh gosh, I'm really messing up. So let's rewrite that for a second. Clear that part of it. The identity matrix is 1, 0, the point, ordered pair, x, y for the blue dot, and then the point for the red, which is 0, 1. Okay, now if that's our identity matrix, that's what we're working off of, and we're reflecting over the line, which is our y-axis, we get the point 1, 0, and that point 1, 0, reflected over that line, eyeball should say, goes there, which is the point negative 1, 0. Now do the same thing with the red point, which is 0, 1. Folding on the y-axis, it folds onto itself, which means it stays the same and would be 0, 1. So there is our reflection matrix for the y-axis, little r sub y. Next, we have one more line we have to be worried about. In geometry, we studied the line, and let's make it so we all can see it. We studied the line y equals x. And that y equals x was that line where you would go right through and pick points like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And we can make it extend into the negatives as well. Negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. So that's the line we're talking about. Now again, if we take our original 2 points, which were the point 1, 0, and the point 0, 1, and writing them in our original setup, they are the point 1, 0 and the point 0, 1. This time, though, we have a new way to write it because we don't just have reflection over the x or the y, we have reflection over the line x equals y. You could even say y equals x. You don't need to say both. You need to say one or the other. So the subscript would be x equals y, y equals x. All right, here we go. Again, taking our 2 original points. If we took the point 1, 0, reflected it over that line, it would end up right there. Oh, so the point 1, 0 becomes the point 0, 1. And if we take our point 0, 1, let's move the blue guy back. If we take our point 0, 1, take the point 0, 1 and reflect it over that line, it goes here. Our blue points need to go back. Let's just get them out of there. And so you can see that we have the point 1, 0. So the point 1, 0 went to 0, 1. The point 0, 1 went to 1, 0. So we have 3 new matrices that we just described that represent our reflection matrices of any points over those lines. So it doesn't matter what our points are. So now let's just regroup and talk about some notes. A reflection we know is like a flip, a mirror image. We're going to use the x-axis, the y-axis, and the line y equals x. So we just showed you what it would look like. So now, when we look at ours here, we have our different reflections. So the first one, reflecting over the y-axis, again, the y-axis took our point 1, 0 and made it negative 1, 0, took our point 0, 1, and it stayed right where it was at. Reflection over the x-axis, that's an up and down folding. The point 1, 0 reflected onto itself, 1, 0. The point 0, 1 went to 0, negative 1. And the last reflection was over the line y equals x. The point 1, 0 became the point 0, 1, and the point 0, 1 became 1, 0. So these will be the 3 new 2x2 matrices we will use for our reflection if we have to multiply any points, any shapes. That's what our conclusions show. So adding to your list, which is now growing, we should have the 3 names, the 3 notations with the correct subscripts. Don't make it a capital R because that's something different. With our 3 new 2x2 matrices, and then ask yourself what's really happening. And visually we said when we reflected over the y-axis, the x value changes to its opposite, but the y value stays the same. And that's exactly what you're seeing in our shortcut. Go to the x-axis. When we reflect something over the x-axis, the points folded top to bottom or bottom to top. So that meant the x value was staying the same and the y value was changing to its opposite. Reflection over the line y equals x says exactly what the reflection is. The x value became the y and the y became the x. So look carefully. They are shortcuts. You should not have to multiply these 2x2 matrices every time you want to do a reflection. Think about your shortcuts. They are very visual. You learn them in geometry, so I hope they are coming back. So if we say reflect this image and we want to be over the y-axis, you could go through and we'll just do this once. You could go through our multiplication with this, but if we can go faster, we want to. But let's just review on this one our multiplication. So if we want to do a y-axis reflection, we've got first row, first column. We've got 4 slots. When -1 times -6, 0 times 4, added together is 6. A -1 times -4 and a 0 times 5 is a positive 4. -1 times -2 and 0 times 3 is a 2. -1 times -3 plus 0 times 1 is a 3. Bottom row, we would do second row, first column. 0 times -6 and 1 times 4 is 4. 0 times -4 plus 1 times 5 is 5. 0 times -2 plus 1 times 3 is 3. And 0 times -3 and 1 times 1 is 1. So as we said in our work, when we reflect over the y-axis, the x's change to their opposite, the y's stay the same. So let's use our shortcut again, saying what happens on the x-axis. When we reflect over the x-axis, that's an up and down. That means our x is staying the same, and our y is switching to its opposite. So if x is staying the same, just copy those x values. And y is changing to its opposite, make every single one of them opposite. That was a little quicker than doing the matrix multiplication. So remembering the shortcuts will definitely pay off time-wise. Reflection over the line y equals x. Again, if we do the shortcut, the reflection tells you exactly what happens. What's x becomes y, what's y becomes x. So in my first point, as -6, 4, that would mean I'd have 4, -6. My next point, -4, 5, would be 5, -4. Next point, 3, -2, 1, -3. So you're seeing the x and y positions switch totally. If we take a shape, same thing, and we reflect it over the different axes, it says reflections differ from size change and scale change in their graphs. The images will be congruent. We're not changing the shapes, we're not changing the angles, we're not changing the edges. So let's do one of these. Let's do the first one, the reflection over the y-axis. If we go over the y-axis, and you have your picture to look at, and you also have your points over here to look at, your y-axis, reflecting over the y-axis, is where the x turns to the opposite, the y stays the same. So we would have a 6, 4, a 4, 5, a 2, 3, and a 3, 1. And if you then draw, connect as smooth as you can, you would have your reflected image over the y-axis. You can do that all the way through. Should be able to do the quick moves. If again I give you a matrix, or I give you the points, you can write them in matrix form and then perform any of the transformations. So if I took those points, 1, 2, write it as a point, 4, 2, 4, 6, and 1, 6, or you could just look at the graph, but since I don't have any intervals on it, it makes it awfully tough. Now you could draw your new one. So again, let's do reflection over the x-axis. Over the x-axis, remember we said the x stays the same, the y turns to its opposite. So if I did a reflection over the x-axis, we should be thinking x stays the same, copy all those, turn the y values to their opposites, and you would be looking at your new shape. You could then move or graph your new shape accordingly. And since we don't have intervals on this one, I won't attempt to do that at this point. So you should be able to draw or rearrange shapes accordingly. So we will be starting on 4-6. It'll just be cover the reading questions to start, but we will be doing a little work with matrices and all the different types of reflections as we go. because we know how to do quite a few of the different transformations now. So make sure you're reviewing all of them, working on memorizing your transformations, the matrices, lists that we have given you, the shortcuts, all of them.